I found a better example. This is a lot clearer because the molecules in it are much bigger, easier to look at. Now, when we look at this, it does look like that all those molecules are moving this way. These molecules are moving along this way. But what did I say before? I said before that we get a movement of energy without a movement of any matter. And this kind of looks like there's matter moving. Okay. Now, of course, each molecule is moving forwards and backwards, but it ends up, on average, back where it began. So, what you can see is if you look at any individual particle or molecule, so you can look at that little red one, but you look at any individual one, what you will see is it just moves forwards and backwards, even the ones in the wave itself. So, if you, for example, let's see if we can pinpoint one here. So if we look at, we've got this wave right here. We've got this molecule just right there. You see it moving forwards and backwards. Part of the wave right now, but no, it's not. Again, part of the wave, but no, it's not. And of course, the whole thing is a wave, but you will see that every individual molecule is just moving by itself. It just moves forwards and backwards, which gives the impression that we've got this overall movement. But you can see, even over this period of time, there's no more on average over here than there is over there. So this is an example of another kind of wave. I'll talk about the words we use to describe them in just a moment. Okay, so I did talk about there being two different kinds of waves. Now you remember when I made the wave on the skipping rope, what we got was this kind of motion here. And you might remember that I mentioned that this graph looks a little bit like a T. Now that T will hopefully help you remember that this kind of wave where we get that kind of motion, where we've got the oscillations moving this way but the wave moving that way, this is what we call a transverse wave. To help you remember, the part trans means across. You'll hear that, transport, transmission, and so it just means that it's going across. We've got the actual oscillations going across the direction of the wave. So you would remember that these are 90 degrees to each other. Okay, so that the oscillations are 90 degrees to the direction the wave actually travels. Great. So let me see, what's the other? Oh yeah, the other kind of wave. So when we get to the wave which is produced in sound, this is not the menu I want. We get this here. Now, obviously it's a different kind of wave. When you look at this, I'd like you to have a think about what direction are the oscillations and what direction is the wave moving in. Do I just zoom into our little red boys there? So you can see that arrow is just pointing at the particle itself. It's not showing you anything else other than just look at this particle. Look at the direction of the wave. You can see the wave is moving this way, and the particles are also oscillating this way. Now what we can then say is, let's just draw on my screen here. Our wave is moving this way, and our particles are oscillating in this way. Actually, the wave is moving both ways as well, because waves get reflected. You know this because sound gets reflected. Otherwise, you wouldn't hear your own voice. So what we've got is these two lines. If I was a bit better at drawing, we would say they are parallel. Okay, so our oscillations and our wave motion are parallel. And this gives rise then to the second kind of waves that we will look at, and this is called a longitudinal wave. So you'll remember our first kind is a transverse wave, and trans being across, so you've got the wave motion this way, the oscillations this way, and the wave motion that way forms a T. So there's your transverse. Now these both go along in the same direction, So this is what we call a longitudinal wave, this one here. And of course, when we think about a transverse wave, we generally get this kind of form. Obviously in real life, it's often much more complicated than that, but we look at it in simplified form at GCSE. So we have got two kinds of waves, longitudinal and transverse. We're going to talk a little later about the properties of both of those, how we can measure different things about them.